Welcome to Study Loop.
Problem 106 in Chapter 7 of Vector Mechanics for Engineers, Statics and Dynamics. So in this problem, there's a cable going from A to E. There's a load applied at B downward and is labeled Q. There's a load applied downward at C, 120 kilonewtons, and a load applied at D in the positive X direction labeled P. The horizontal distance from A to B is 4 meters, B to C is 4 meters, C to D is 4 meters, and D to E is 4 meters. There is 2 meters in the vertical direction between A and E. There is 4 meters in the vertical direction between A and B. And there is 2 meters in the vertical direction between B and C. So our task in this problem is finding P and Q that maintains equilibrium in this problem. So we're going to start off with drawing a free body diagram between D and E and include the reaction forces at E. EY is placed in the positive Y direction and EX in the positive X direction. So we're going to do the sum of moments around D and set that equal to 0. So this will be EY times 4, because there's 4 meters in the horizontal direction between E and D. And then EX times 6, because there's 6 meters in the vertical direction between D and E. And set that equal to 0. I'm going to go ahead and solve for EY, which is 3 over 2 EX. We're going to need this problem later on. We're now going to draw a free body diagram between C and E. And we're going to do the sum of moments around C and set that equal to 0. And this would be EY times 8, because there are 8 meters in the horizontal direction between C and E, minus EX times 8, because there's 8 meters in the vertical direction between C and E, and then subtract P times 2, because there's 2 meters in the vertical direction between C and D. We're going to go ahead and plug in this value into this equation and solve. Or simplify. So it'd be 3 over 2 EX times 8 minus 8EX, and move the 2P to the other side. We're going to go ahead and solve for EX. And this equals 1/2 P. Now we're going to draw a free body diagram from B to E. We're going to do the sum of moments around B, and that equals 0. So this will equal EY times 12, because 12 meters in the horizontal direction between B and E, minus EX times 6, because there's 6 meters in the vertical direction between B and E, and subtract 120, which is the force at P, times 4, because there's 4 meters in the horizontal direction between B and C. We're going to go ahead and plug in this equation for EY to simplify. So this will be 12 times 3 over 2 EX minus 6 EX. You can go ahead and move this to their side. It's 480. All right, and now we can plug in this EX into this equation. So this will simplify down to 18 times 1/2 P minus 6 1/2 P equals 480. So now we can solve for P. P equals 80 kilonewtons, which is one of the solutions to this problem. Now it's time to solve for Q. We can draw a free body diagram from A to E, including the reaction forces at A. AY is in the positive Y direction, and AX is in the negative X direction. So we're going to do the sum of moments around A and set it equal to 0. So this equals negative Q times 4, because there's 4 meters in the horizontal direction between B and A. Subtract 120, which is the force at C, times 8, because there's 8 meters in the horizontal direction between C and A, plus P times 4, because there's 4 meters in the vertical direction between D and A, plus EY times 16 because there's 16 meters in the horizontal direction between E and A, minus EX times 2 because there is 2 meters in the vertical direction between A and E, set that equal to 0. So now we are able to substitute the two equations that we found earlier so we can carry it down. We know EY equals 3/2 EX, and then EX is equal to 1/2 P. So we can plug those into this equation to simplify. So it'll be negative 4Q minus 960 plus 320 plus 16, 3 over 2 times 1/2 P minus 2, 1/2 P. Set that equal to 0. So once we simplify all this down, plugging in P, which was 80 kilonewtons, we can go ahead and completely solve for Q, which equals 60 kilonewtons, which is the second answer for problem 106. So the final answer is P equals 80 kilonewtons and Q equals 60 kilonewtons.